Welcome to today's Think Small Cell webinar entitled 3G and LTE Enterprise Small Cell Architectures. I'm joined today by Amit Jain, VP of Marketing and Product Management at SpiderCloud Wireless, who's kindly sponsored this event. And both of us will be giving a short presentation followed by a Q&A session. Just in terms of housekeeping, the slides that you'll see throughout the webinar, together with a full recording of the entire event, will be uploaded and made available to everybody, and you'll get an automatic email, normally within the next 24 hours, with links to both of those. At any point during the webinar, feel free to pose a question to us. You can submit those on the panel on the right-hand side of your screen, and we'll cover those in the Q&A session at the end. And last but not least, both of us will be attending Small Cell World Summit in about 2 weeks' time in London, and you'd be very welcome to speak to either of us there. So what I'm going to do first is just introduce some of the market trends and status of enterprise small cells before I hand over to Amit to discuss some of the technical aspects of how the industry is resolving and addressing those issues. Now, one of the terms we often hear is the question of why small cells haven't taken off yet. Every year we have the statement that this is the year of the small cell, and whether you see that as crying wolf or compared to the popular film Groundhog Day, every year it seems to be delayed by a further year. So why haven't small cells really taken off in huge volume yet? I'd like to point to maybe three key reasons, at least in the enterprise market. One is that there was a big swathe of LTE, both technology and spectrum, that came on the market about 3, 4, 5 years ago. That includes spectrum down at low frequencies, 600-700 megahertz, that have allowed the range of existing cell sites and in-building penetration to be improved, and it's quite an easy method in the sense that it uses the same process to increase the capacity and range of networks, and LTE itself, of course, operates at very much higher speeds. We've also seen that every smartphone that's sold today has Wi-Fi capability, and most users would make use of that, typically in private networks, so at home or in the office, and typically for data use rather than in public areas for voice. And thirdly, small cells are very much locked to a single network operator. And what we're seeing in the enterprise, and particularly in public venues, is that building owners want all their guests, and enterprises want all their staff to be able to use the system regardless of which network operator they're with. And we've not yet got either a neutral host or a multi-operator small cell solution that's popularly deployed. However, there is very much still a strong pent-up demand from enterprises, and that's evidenced by the fact that property rental values, even the ability to rent properties in some cases, is strongly affected by the availability of good cellular service indoors. So there is a growing emphasis on indoor solutions. There is a lot of equipment that we can deploy outdoors, but in some respects, this outdoor-in approach is reaching its limits. And a couple of evidence points there. Vodafone made a public statement last year that after spending over £200 million, that's about $300 million, upgrading their cell sites throughout London to provide good LTE service and reaching inside many buildings, there was still something like 40% of the areas that are deep inside unable to be serviced by this outdoor-in approach. And we've seen evidence from other regions. China Mobile, for example, deploying a lot of enterprise small cells in North America. Verizon deploying a lot of equipment to ensure that there's a high quality and a high capacity both indoor and out. I think secondly, there's more commercial value in selling a data service that runs on LTE versus offering a Wi-Fi service that's typically perceived to be free. Perhaps one public evidence of that is EE, a UK operator, who publicly position themselves for being the network of onload. They want more traffic on their network, which they can then manage and charge for, rather than offloading to Wi-Fi, which they would not see and would not be able to gain revenue from. And thirdly, we're seeing some movement towards neutral hosts. There are some initiatives which are making progress. We see some operators who see more value in differentiation and want to have their own networks completely independent and be measured compared with others, whilst some operators see value in collaborating in certain scenarios and certain situations where they can provide and share the cost of the solution that's deployed. Another aspect to consider is this view of whether you would deploy a 3G only system or a 4G only system, or in fact what you need today is a small cell that's capable of both simultaneously. And the reason for that is that we're in this transition stage between 3G and 4G, where in many countries an LTE only solution isn't yet viable. VoLTE is the method of deploying voice on the LTE network, and surprisingly, it's not yet that widely deployed. There are something like 20 commercially deployments of VoLTE. There are many at an advanced stage of trials and expected to be rolled out during this year. But there are also many networks who use the circuit switch fallback to 3G, not just as the solution today, but likely to be the case for some time. It's technically quite a complex transition to move your 3G core network across to 4G, and a big project in its own right. There's also a substantial proportion of handsets that are still capable only of 3G, and it will take time for LTE capable handsets and VoLTE capable handsets to become a greater proportion of the total installed base. There are a few pioneering networks, of course, Verizon in the US, China Mobile, perhaps, who both have had a slightly different version of 3G from the mainstream UMTS that is most popular worldwide. And so they are setting the pace for the transition. The investment in 3G only product may be considered as a limited term investment. You might say to yourself, well, why would I deploy something that may only have a lifetime of a relatively few years? And so the ideal solution for some is to have a product that's capable of both 3G and 4G. And we do have a number of small cells that are able to step up to that mark. Some recent multimode deployments include the operators I've listed there, T-Mobile USA, American Mobilis in South America, very large deployments in Vodafone and other places. And clearly the answer to this question of 3G or 4G or multimode varies depending on what region of the world you're based in. So on the left-hand side on this chart, you can see that North America is already got a very substantial base of 4G and is likely to achieve something like 95% within 5 years. Europe is somewhat behind. We've had perhaps more investment in the WCDMA 3G system. It's very popular, but we're expecting a fairly rapid transition, and we'll catch up with North America, also 95% over the next 5 years. Asia Pacific has perhaps a slower migration rate. There's still a large number of people on GSM in some of the poorer developing countries in Asia Pac, and so the time frame and the proportion there is lower. And then looking at Latin America, as you can see, very little LTE deployed today, and something like 40% over the next 5 years. So depending on what region you might be, the answer to which technology suits you best and what time frame will vary. And the other thing to consider is some of the forthcoming developments in the pipeline. We have LTE augmented access, which is a method of boosting an LTE service by adding an extra download channel on the 5 gigahertz unlicensed band to make it go very much faster. We have multi-fire, which operates LTE effectively entirely in the unlicensed spectrum, typically at 5 gigahertz. And we have some proposals to share spectrum in quite a novel way at the 3.5 gigahertz band initially in the US. And the latter two of these forthcoming developments are quite suitable for a multi-operator or a shared deployment. And certainly all of the above are highly suited towards small cell technology, perhaps more so than using DAS or a centralized RAN solution, depending on the precise architecture involved. So having made just a few opening remarks here, I'd now like to ask the audience for your own view about what is the importance and time frame for 3G and 4G multimode enterprise small cells. A good response to that, and as you can see, 25% thought that the story is really 4G from now on, 32% thought that multimode is good for the next couple of years. The highest proportion thought that multimode was really good for something like 3 to 5 years, and actually nobody thought that 3G was the answer for all cases from now on. So what I'd like to do before I close that poll result question is I'd just like to ask Amit for his comments on that response, and then would ask him to follow on through with his presentation. Over to you, Amit.
Thank you, David. Results are really interesting, and I think it is a reflection of where operators around the world are in terms of rolling out LTE. I think, as you mentioned earlier, there are some parts of the world where LTE is quite widely deployed, and perhaps 4G only small cells might be the answer. But as we are seeing from the poll results, it looks like in most parts of the world, it would make sense to have multimode 3G and 4G small cells so that carriers can leverage their investment in small cells across their, practically their entire customer base. So really interesting, and I think this is a good segue into rest of our discussion, which is focused on how do we design small cell systems in enterprises, and how do we design them for both 3G as well as LTE. I'm really excited about the opportunity for enterprise small cells. The demand for enterprise small cells is driven by the need for network capacity. We've all seen how the demand for mobile data is growing, and it continues to grow. As most of the big operators now have built out their LTE networks and now have millions of subscribers on these networks, to compete, they need to provide these subscribers a great user experience. They need to provide them the capacity to do all the things that they want to do in the network. They want to do it in a seamless fashion. They want to do it without customers experience call drops, etc. So that is going to be the key for differentiation, the key for retaining and acquiring subscribers. And small cells play a really big part in making that happen. When I look at the enterprise small cell market, I would broadly divide it into three market segments. The first segment is for small offices, home offices, maybe even places like restaurants, bars, retail. These are buildings that are smaller than 5,000 square feet. And for this segment of the market, there are two options when it comes to small cell architectures. It is either consumer femtocells or even using Wi-Fi. The second segment is the small and medium enterprise segment. These are buildings that are larger than 5,000 square feet, but still smaller than 50,000 square feet. And here carriers have an option of using either enterprise femtocells or indoor picocells. And then the third segment is medium to large enterprises and venues, where they can either use the baseband unit that they have in their macro network connected to remote radio heads, or they can use enterprise small cells with an enterprise controller. In this chart, I've also shared how the size of these different segments is distributed in the US market. Of course, the small office, home office segment has the largest number of buildings, but the amount of floor space is limited. On the other side, when you look at these really large buildings, the number of buildings is small, but often these buildings cover a very large amount of the commercial floor space. At least my view is that as carriers are building these networks, they have to look at how they're covering the largest amount of floor space, because the floor space is representative of where the subscribers are. So this is something that the carriers have to think through, which segment they go after, and after they look at that, try to look at what is the right architecture for that segment. When it comes to picking the right architecture, there are three main things that carriers have to consider. The first is, what is the total cost of ownership? And what is the total cost of ownership on a per subscriber basis? Now, TCO has multiple elements. Of course, it has the cost of small cells, but then it also has the cost of installation. And then the ongoing costs. So if you have to buy capacity licenses, if you have to get software upgrades, the continuing cost for backhaul, site leases if necessary, and so on. And then this TCO has to be divided by the number of subscribers that they're serving. So if you're an operator with lots of LTE subscribers, maybe an LTE-only system is adequate because that's where 90% of your subscribers are. But if you have a mix of both technologies, you need systems that can support both to get the lowest possible TCO per subscriber. The second thing they have to consider is the capacity. And not just the capacity of like a single small cell, but the capacity that is delivered across a building, across the enterprise. And there they have to look at what is the total number of cells that they've deployed and divide that by the coverage area that they are serving, which gives them the capacity per square feet, or the capacity per square meter. And finally, once they've deployed the system, there's no point of doing so if they have not provided a great user experience. This means that there must be seamless mobility inside these buildings, must be a consistent throughputs, and maybe in the future a way to provide value-added services to subscribers. What I'm going to do next is try to look at the different small cell architectures that we looked at on the previous slide in the context of the different market segments, and see how they help in meeting these different criteria. So with kind of these in mind, let's look at the different architectures, starting with a comparison of indoor picocells and enterprise femtocells. So let's see, what is an indoor picocell? An indoor picocell is, at least in my view, is basically a scaled-down version of a macro base station. Typically, indoor picocells are provided by the same kind of companies in your network who might be providing macro base station equipment. And they do have the benefit that often they'll be able to offer, same kind of features, the same kind of functionality that you have on your macro network. They will connect back to the core network that you have in place in that market. So a 3G indoor pico can connect back to the 3G RNC that you're using in the macro network. Yes, you might need more capacity licenses on the RNC, but you can still connect to the RNC that you have. It will connect back to the EPC in the same fashion. And it might even be, it will most likely be managed by the same EMS, the same element management system that you have for macro base stations. Now, of course, since it is working like a macro, it would require often require managed backhaul. So the same kind of backhaul that you take to your cell sites, you might require similar backhaul to the building where you deploy these indoor Picos. For synchronization, I've seen that most indoor Pico products either provide a GPS or integrated with the Pico, or they might offer an option that you can install a IEEE 1588 server inside the building, and then all these Picos could be synchronized over 1588. So that's one way in which you could do a Picocell deployment. Yes, I think if you're connecting to an RNC, you can definitely offer features like, say, soft handover between these Picocells. The alternate approach for small and medium enterprise segment is to use enterprise femtocells. Now, the main difference between the femtocell and the Pico out here is that the femtocell is, at least on the 3G side, is integrating the RNC software stack and then connecting to a home node B gateway over this interface that is known as IUH. The benefit of connecting over IUH is that now you can connect using internet backhaul. So maybe, like a lot of the femtocell technology that was initially was developed so that the femtocell could even work over, say, DSL or cable style home broadband networks. And that benefit of backhaul flexibility kind of becomes available when you're doing an enterprise femto deployment. A lot of enterprise femtos do come with GPS, and they use that for synchronization. One of the constraints of enterprise femtos is that because you have now moved the 3G RNC functionality all the way to the femto, is that you can no longer offer soft handover as long as you're complying with the IUH standard between enterprise femtos inside a building, and this might lead to call drops, especially on the 3G voice side. Secondly, it also requires the installation of these new gateways. So as a carrier, you have to consider, do you want to actually get a home node B gateway for 3G, and then also a home E node B gateway for LTE. Femtocell systems will most likely require a new management system as well in the network. However, most of the femtocells do support some kind of self-organizing network or SON functionality. They're able to listen to the macro environment, and I believe that a lot of companies in this space have done a lot of good work in terms of trying to make these systems femtocell systems as easy to provision as possible. So the key decision point really for a carrier becomes, are they looking for a system that has like eFemto, which might be able to offer them, say, lower ongoing OpEx because they can use lower cost backhaul and they can rely on the SON functionality. But at the beginning, they would have to put in, say, these new core network gateways. While if you look at a Picocell solution, that is a natural extension of whatever you're doing in the macro network. So just kind of moving on the when it comes to larger buildings, as I mentioned, carriers have two choices. They can either use remote radio heads with the baseband units that they are already getting on their macro network. So in this, or they can use enterprise small cells with a controller. When you look at architectures with the baseband unit, a baseband unit is typically the same unit that you're using as part of your macro. It supports CIPRI interface, and it connects via CIPRI to some kind of a radio head aggregator over fiber. And from there on, it connects often using structured cabling, so often category 6 or category 7 cabling, off to the remote radio heads. So these systems again integrate really nicely with the existing core network that you have in place. The main constraint to look at here is the amount of capacity that we deliver, because the capacity is decided by whatever the baseband unit is able to offer. So if the baseband unit was put in with, say, 3 sectors of capacity, that is the capacity that's going to be distributed across the building. If it was put in with 6 sectors or 12 sectors, well, that is the capacity you have inside the building. Often, as you're adding capacity, you'll have to go to the cell site, add new baseband processing cards to the baseband unit, or in some cases purchase capacity licenses from the supplier of these systems. Another thing that I've noticed with these systems is that the remote radio heads do not support any radio environment monitoring capability. So as a result, the system completely relies on the EMS system or the centralized song systems that are integrated with the macro EMS system for the configuration of all the radio parameters in these products. The alternative architecture for the larger buildings is to use small cells, enterprise small cells with an enterprise controller. Now, in this architecture, the small cells connect to the small cell controller over the Ethernet LAN inside the building. Each small cell is capable of providing, in some cases, 1, in other cases, 2 sectors of capacity. And these two, when I say a sector of capacity, this would be, another term would be a cell of capacity. So this could be a cell of UMTS capacity or a cell of LTE capacity. And if you had a system that, had 100 small cells in this building, from a capacity standpoint, you could be providing as much as 200 sectors of capacity within this building. The role of the small cell controller in this architecture is to make deployment easy and to deliver the performance carriers expect. So the small cell controller would manage all the mobility inside the building. If there is any handover between small cells, that would be handled by the controller. It doesn't have to go back all the way to the EPC or the ROC, the home node gateway. From the perspective of the core network, this entire system appears as a single eNode V or as a single home eNode V. The small cell controller is managing all the interference inside the building. It's providing SON inside the building, and so on. Further, depending upon the design of the controller, having it can remove the need for a home eNode V gateway in the LTE case. In the case of UMTS, in this architecture, you would still need an IUH or a home node V gateway. And because doing that allows you to then use internet backhaul when you're doing these deployments. Also in the case of 3G, all the handover functionality is, the RNC style handover functionality is handled by the small cell controller. So you're able to get a system where on the 3G side you have soft handovers. On the LTE side you have very fast handovers because the handovers are being done locally without the signaling traffic going back on the backhaul network. Just like enterprise centers, most of the enterprise small cells in this architecture will also support radio environment monitoring capability. This means they're able to sense both the presence of other small cells as well as macro cells in the network, and then use that information for automatically configuring RF parameters such as neighbor lists, PCIs, VSCs, transmit powers, and so on. At this stage, I think I'm going to hand back to David, who wanted to conduct another short poll. David?
Thank you very much, Amit. Yes, so the question we're going to be asking now is really about which type of spectrum you think would be most widely deployed using LTE over the next 5 years. And you'll see on your screen now the choices there. So whether you think that not necessarily small cells, but any in-building system, even outdoor in system that's using LTE, would that primarily use licensed spectrum, or would we expect in 5 years' time that to be augmented by LTE also running at 5 gigahertz in the unlicensed band there, using something like LAA? Would we expect huge take-up in shared spectrum solutions, such as we're seeing proposed for 3.5 gigahertz? Would indeed we expect unlicensed spectrum at 5 gigahertz to be the primary solution? Again, we're talking about LTE here. Or is it just too difficult and there's just too many unknowns to be able to make a choice? So let me just share the results. So there seems to be a very popular, or very strong support for LAA there. Any thoughts on that, Amit?
Thanks, David. I think the opportunity for using unlicensed spectrum to deliver more capacity is a really big opportunity for small cells, and I think we can see it that at least looks like 56% of the of the respondents do think that unlicensed has a part to play. I think LA is definitely a much nearer term than 3.5 or unlicensed completely 5 gigahertz, and probably that is what is showing up in the feedback that we are getting from our participants. So I'm very excited about the opportunity of using enterprise small cells in unlicensed spectrum, and I think it can help both in terms of delivering more capacity to carriers in indoor environments, as well as to start addressing some of the neutral host, the concerns about how do we use small cells for neutral host deployments. So probably there are three, as you picked up in the poll, there are three technologies. There is licensed assisted access for LTE, and in this case, the LTE licensed channel remains the primary anchor for the subscriber, and unlicensed spectrum is really used to kind of, if you may, boost the capacity that you can get on the licensed band. So often the main benefit of LAA is that you can get twice the capacity without deploying twice the licensed spectrum. But it is really geared towards doing single operator small cell deployments. The other two options, whether it is multi-fire or using authorized shared spectrum, can help in doing neutral host LTE in venues. However, a lot of work remains in terms of standardization of these technologies, as well as getting regulatory approval for them in different markets, especially for the authorized shared spectrum case. Now, I believe that once we start using unlicensed spectrum, small cells that have the baseband at the edge will be essential. And let me explain why. So when you're using unlicensed, when anybody is using unlicensed spectrum, it is actually competing for the use of that spectrum with other users. So imagine that there is an LTE base station working in the same spectrum as a Wi-Fi access point in the same channel. Both the LTE base station and the Wi-Fi access point are continuously assessing if the channel is available, if it is free. And at that end, once the channel becomes free, whoever needs to use it notifies the other users of the spectrum and then goes ahead and transmits. So, and in this entire loop of assessing whether the channel is available, reserving it through some form of notification, and transmitting is often done in microseconds. So it is essential that whatever architecture is used and does it that fast. And I believe that small cells are absolutely able to do it, because in a small cell, this unlicensed spectrum monitoring capability, as well as the LTE physical layer and scheduler, are all co-located, enabling this to be done. What I do think is that alternate solutions, let's say when you use centralized RAN architectures in which you have a baseband unit that is being shared across lots of radio heads through a remote radio head aggregator, would not work that well. And for two reasons. First of all, the baseband unit will lose opportunities to use the spectrum because of the delays between measuring the channel, which is done, the channel measurement is done at the radio head, and then scheduling the packets to use that channel, which will be done at the baseband unit. So, so if it is not possible to close this loop fast enough because of the delays, then the LTE node B will continuously keep on losing the opportunities to use this spectrum. The second issue is how this architecture would coexist with the Wi-Fi system. So as you can see in this picture, whenever the area in the blue shows the coverage area of a single LTE sector inside the building, and then you see the smaller circles representing the Wi-Fi access points. So whenever the LTE base station transmits, it will, its transmission will go over it will basically cover multiple Wi-Fi APs, causing interference to all of them, and in that sense, reducing the capacity that you would get on the Wi-Fi system. At this point, I would like to take a few minutes of your time to introduce SpiderCloud's solution. SpiderCloud builds a system that can be used to provide coverage and capacity in medium to large buildings. Our system is built on the small cells with enterprise controller architecture that I had discussed earlier in the webinar. We build three kinds of small cells. We build a dual mode, 3G and LTE small cell that we supply to operators like Vodafone and America Mobile, who have a substantial number of UMTS subscribers in their network. We build a small cell that does 2 carriers of LTE with carrier aggregation. And this is a product that we are today supplying Verizon Wireless, which has rolled out LTE nationwide and has launched voice over LTE. And finally, we are working on an LTE LAA product. We'll be taking this product into trials at Verizon in the later part of 2016. And this helps our customers who have deployed LTE provide even more capacity in their network. The LTE LAA product is also designed for operators who have a really small amount of LTE spectrum. For instance, if they haven't done a spectrum auction in their a spectrum auction hasn't happened in their country, and they would like to take a small amount of GSM spectrum, reform it, and then combine it with, say, 40 megahertz of license. That is something we could do with an LTE LAA product. All our small cells then connect over the Ethernet LAN to our enterprise small cell controller that we call the services node, and then the services node connects to the carrier's core network. Our solution is based on a cloud RAN architecture, particularly in the LTE case. So what we have done is that we run the physical layer, the MAC layer, and part of layer 3 on our small cells, but then we centralize the remaining layer 3 functionality, the RRC functionality, as well as other functions such as security, management, synchronization, and so on, and then make this entire system appear as a single eNode B connecting via a single S1 link back to the core network. I think that this architecture provides tremendous advantage to carriers in terms of driving down the cost of small cell deployments right now, because our small cells connect to a controller over Ethernet. Since we are running layer 1 and layer 2 on the small cell itself, we are not reliant on using some kind of low latency dedicated front haul link. We're able to use the Ethernet that exists in the enterprise. Secondly, we're able to use a low-cost, low-power system on chips, which allows us to drive down the cost of the small cells now and moving ahead. And finally, as I had mentioned earlier in the webinar, this architecture is better suited for implementing technologies in the unlicensed band, because the unlicensed spectrum sensing capability and the LTE scheduling capability is on the same board, so we can meet the tightest timing requirements, the really tight timing requirements that are necessary in the unlicensed bands. So that's where we are, and look forward to any questions from you, David, or from the audience.
Thank you very much, Amit. So we have a number of questions already come in, and I'll just see if I can find a kind of grouping between several questions of a similar nature. I think one of the first questions is actually around Wi-Fi, and particularly voice over Wi-Fi. So what is the impact of voice over Wi-Fi, particularly in this enterprise sector, on the small cell market?
Well, that's a great question, and I do get that question from a lot of our customers and analysts as well. I think what we have, after looking at it, we are actually not seeing a big impact of voice over Wi-Fi on enterprise small cells, especially in the medium, in the kind of in the larger enterprise segment, or in any environments where there is a high density of subscribers. This is happening because one of the fundamental limitations of, even though voice over Wi-Fi, by the way, is a great technology and works in lots of cases, the limitation that Wi-Fi has is that a typical Wi-Fi access point, just by the design of the CSMA CA method in Wi-Fi, there's a limit on the number of voice over Wi-Fi users that you can support on a single Wi-Fi access point. Most Wi-Fi access point vendors agree that it's around 8 voice over Wi-Fi users. So if you're in a home environment, that's fine. But let's say if you're in a big enterprise, that's a problem. You can of course solve it by deploying by kind of densifying your Wi-Fi network, but this means a pretty large expense. LTE small cells on the other side are able to easily offer, say, even 64 or 128 simultaneous VoLTE calls. So in that sense, the cost of building LTE small cells is much lower than what you would get by trying to do the same thing by densifying your Wi-Fi network. The other reason why we see larger enterprises looking at LTE rather than voice over Wi-Fi is the question of how does it impact the enterprise LAN network and an enterprise IT itself. The moment an enterprise starts supporting voice over Wi-Fi, their IT department really becomes responsible for voice calling. And every time your cell phone doesn't work, you don't complain about your operator, you now complain about IT and their ability to build a proper Wi-Fi network. So a lot of IT people are pushing back and saying, look, this is the carrier's responsibility. They need to fix it using the technologies they have rather than burdening us. In some cases, voice over Wi-Fi also means that they have to open up firewalls in their network, which, based on conversations with a lot of IT people that I've had and others at SpiderCloud have had, that is something that they really don't like to do. So for a number of reasons, for all these reasons, we are continuing to see strong demand for LTE small cells and 3G and LTE small cells in the enterprise segment and in public venues.
Okay. So one question from me this time. I said in my introduction that one of the barriers, one of the constraints to more rapid adoption of enterprise small cells has been this perceived lack of multi-operator support. They're typically locked to a single network operator. What commercial or technical solution do you see as being appropriate to resolve that?
When you look at any indoor deployment, it has two elements. One is just all the cabling that you have to put in and all the installation work you have to do. And then second is the base station functionality that you're bringing in. And even if you look at today's multi-operator systems using technologies like DAS, often, even though the kind of the DAS cabling is shared, every operator is still bringing in their own base station to drive this so-called neutral host multi-operator system inside the building. At least my view on the small cell space is that as long as small cells can be deployed over the Ethernet LAN, and that LAN can be shared between multiple operators, you can actually do multi-operator deployments inside the building without necessarily having small cells that are actually being shared by the carriers. Sharing a small cell is like sharing a base station, and most of the carriers right now are not sharing their RAN or not sharing their base stations. So I think trying to go towards base station sharing is problematic. But if we can, as long as we are designing the networks over the Ethernet LAN, you can take out a significant amount of, tremendous amount of cost, I would say, and still let each operator have its own base stations. And then we can further share the operating expense between operators by using internet-style backhaul connecting back to the core network. So that OpEx also gets shared. And I think with that, we can do multi-operator systems today. In the future, of course, we have other options like using multi-fire and 3 or 5 gigahertz spectrum and so on. But those options are a few years out.
So in my mind, I have the idea that we've got a real proliferation of small cells deployed, because you've got a whole stack or set from operator A, and another duplicate set from B, and another duplicate set from C. Does that mean you'd have so many small cells deployed that they'd outnumber the Wi-Fi access points we have in place?
No, not so. See, a typical LTE small cell covers 10,000 to 15,000 square feet, sometimes even higher depending upon the transmit power of the small cell. A typical Wi-Fi access point covers around 3,000 square feet. So I would say that even so look at it this way, if you had a 100,000 square feet building, you would probably require, say, 30 Wi-Fi access points, right? So a little over 3,000 square feet of Wi-Fi access point. Same building would require just 5 to 6 small cells per operator. So even if all 4 operators came in and deployed small cells, you would still have fewer small cells than Wi-Fi access points. And you don't have to put all of them at the same location. You can basically interleave, kind of deploy them throughout the building in a way that at a certain location on the ceiling, you only have a small cell from one of the carriers. In fact, we have a couple of partners who have been public about how they're looking at using, say, the SpiderCloud small cell solutions to do exactly what I'm describing.
Oh, that's interesting. All right, last question. We clearly had in the poll question a lot of support for LAA as an unlicensed augmentation or boost. So one of the questions is, why would an enterprise install LAA or permit LAA to be used if they already had a very extensive and successful enterprise Wi-Fi deployment? Would that replace it or be seen to complement and coexist with the Wi-Fi?
It's a great question. So I kind of look at LAA as a technology for mobile network operators, not exactly for enterprises. So if an enterprise IT group really wants to run their own network, then perhaps Wi-Fi is the best way for them to go. They cannot even use LAA because LAA relies on using the primary channel is a licensed channel. On the other side, if the enterprise is open to the idea of letting the carrier come in and just provide managed mobility inside the building, so the enterprise IT says, look, I don't want to be in the business of running this, like a wireless network inside my building anymore. I would like one of the big carriers to come into it. At that stage, I think the carrier would like to use LAA because Now with the limited amount of licensed spectrum, they can provide a tremendous amount of capacity inside the building. So I think that's how the decision will be done. The other place where I see LAA being used is in actually public venues. So if you look at a large shopping mall, and even if this large shopping mall has, like dozens of Wi-Fi networks from the mall and from every store and so on, if now a big operator wants to provide a service to their subscribers inside this shopping mall, rather than relying on Wi-Fi, they can deploy an LAA system where their subscribers are always guaranteed to get access to the licensed spectrum, and they can get higher capacity or higher throughput depending upon the availability of unlicensed spectrum and how it all coexists with the existing Wi-Fi. So I think that's another huge use case for LAA.
Thanks very much, Amit. I'm afraid we don't have time to run through any more questions. We have quite a few in the pipeline. Somebody was pointing out that, for example, in Australia, that the networks are already sharing base stations there, so perhaps they're setting a model that can be adopted elsewhere. So before I close, I'd just like to point out that in a couple of weeks' time, we're coming to a major event for the small cell industry, Small Cell World Summit, or SCWS World, as it's now called. Both Amit and myself will be there, and so if we weren't able to answer your questions on the webinar today, we'd be more than happy to do so in person at the event. I'm also going to be moderating a panel session on multi-fire and making a short presentation about LAA on the workshops in the first day, and I'll be posing some questions to some panelists also around enterprise market segment later in the event. So do come and attend those if you are at the show. In the meantime, I'd like to thank you all for your attention. We've had a very good turnout, and for those who are watching the replay and the recording, I hope you found this a useful and educational webinar. Thanks very much for your attention.